Hi all, my name is Akash Ashok. I'll be your host for today's session. So, I don't know how many of you are from third year or fourth year, or how many of you have tried to write a paper. But those who have tried to write a paper or those who have tried to learn about LaTeX, you might have faced difficulty. As in, just to start off, it is quite difficult to understand. But once you have learned the basics, I think it's really easy to manipulate and make your own reports. So, here we have Associate Professor Shiney Thomas from Amarjyoti College of Engineering. Uh, Ma'am has an amazing knowledge on latex, and I think in the coming 1 hour we'll be learning the basics on how to build a sample report, which will have including tables, let's say images, equations, and all. So, over to you, madam.
Okay, thank you, Akash. I hope I'm audible to all.
Yes, ma'am, you're audible.
Okay, so a very good evening to all and all. So I had asked Akash whether we know what background you all are from, whether you are from CS or EC, because it will be easy for me to speed up. So that's all. So without wasting time, I'll move on to the presentation. And okay. So what we're going to learn today is just an introduction to LaTeX. It's basically a document typesetting tool. And as Arthur said, I'm Shani Thomas. I'm working in Amazon since the past 17 years. And all the BTech and MTech students are very familiar at Amazon, are very familiar with this tool. And that is how we do our seminar reports and project reports and all. So I'm sure it will be useful for many of you, those ones. So I'll just give you an introduction because the thing is that this workshop should have actually been, this should have been a workshop actually. It cannot be just a 1 hour session or a 2 hour session. We need at least 2 days for completing it well and good. So if parallelly you were able to do it while I was also showing you the code, it would have been better. So anyway, I'll just give you an intro so that many of you can start doing it and then we can follow up later as required. So what is LaTeX? An introduction that I can give you is the you can see the name that is given over here. It is basically TEX. The terms you can see over here. That is basically three mathematical symbols. You can say the Greek symbols tau, epsilon, and chi. So it is pronounced as tech, not text. The pronunciation of X is not as X, but it is as CH. Okay, so tech is basically a markup language. I hope all of you know what is meant by HTML, XML, etc. Because those are other similar kinds of markup languages that HTML especially we use it for web browser. We all know that, right? So for rendering pages on a web browser, we use HTML. And HTML is in the form of tags. So similarly here also, LaTeX will be having a lot of tags basically, and you'll be using those for creating the document. So it is not like what you see in a Word document. All of you know what is a Word document. In simple words, I can say it is like this. What WYSIWYG. This a word, as a word program works like that. Like what you see is what you get. So whatever you see on your monitor or on the screen where you're typing the document is what you get as output on a printer. But that is not the case of LaTeX. Because in LaTeX, you'll be actually coding, that is, you'll have a combination of code as well as you'll have a combination of text, both of them together, images, whatever it is. So, whatever you want in a document will be accompanied with some code, and these two together will be giving you the output, but the output will not contain any code. It will contain only the document as you see in Word. So, that is the advantage of, you can say, one of the advantages of using it. And of course, it is very beautiful to look into. Now, who developed it? It was developed actually by Donald Moore in the 1978 or something. It is actually a revolution in typesetting. So, typesetting, we all know what is a typewriter and how typesetting and how books were created in earlier days. And you can see over here that now this is a kind of digital or a computer based typesetting, isn't it? So, the extension of tech was known as LaTeX. Okay, now when I say LaTeX, so remember the pronunciation, X sounds as CH. So that is why I've written over here. You can either call it as LaTeX or you can also call it as LaTeX. Both are the same. And this was actually extended by a second person, that is Leslie Lamport, and in 1980s. And why do we use it? Of course, to create your any kind of scientific document or academic document that you have, you can create it using this. It has excellent visual quality. It's very good for creating mathematical formula, and you can also have a very good or simple way or method of creating table of contents, list of figures, list of tables, etc. And many other advantages are also there. So I told you, unlike Word, this has to be compiled first. So that is one of the thing that you have to do here. The compilation part is very important. Okay. Now the tools that you can use here, and because this is a online kind of webinar, the only option for me is, I think if you also want to work together without, so I cannot go into detail of installation and all, the best option is going for Overleaf. So Overleaf is an online LaTeX tool or editor where you can actually work in collaboration. If you have a team of people doing your project, you can have a team of collaboration and Overleaf. It's not just, it's like a distributed system, you can say. So Overleaf, you can say, or share LaTeX, CoCal, so many things are there. So the best one I've seen so far is Overleaf. And of course, you have a free, without subscription, you can just register yourself and start using it also. If you want more features, of course, you have to subscribe as a premium user. Now, if you're doing it offline, that is on your computer, I suggest you install these two tools. That is, one of them is this. You can install TechMaker as well as LaTeX. These two. So there are many other options also, but these are the most common ones that I use. So LaTeX is actually the compiler that helps in doing this execution, and TechMaker is the, you can say, the graphical user interface that helps you. So you can just search in Google for Windows or Linux or whichever OS you're using. Just search TechMaker and LaTeX and install both of them, and open TechMaker and you can start working there. So basically, in order to create any sort of file, because you have to create a document, right? So in order to create a document which is a combination of commands and text and images and tables and so many things. So you need to have some extension for the file. So you can see the extension used here is .tex. So the name itself is .tex. And how do you view this output is the LaTeX actually creates a number of formats for outputs. It can be either a PDF or a PostScript, or you can have even some other kinds of device independent files also. So whatever be the, because we all are creating reports and we prefer that we do it in PDF, because so that it is, what do you say, it cannot be changed, or when you go from one place, it's portable, you can say. When you move from one location to another, the format, the alignment, all these should not change. If you're using a word and you're porting it, a possibility is that a lot of alignments and a lot of, changes can come in the document. Okay, so it's better you always compile it and get the PDF output. So if you want a PDF output, the compiler that they actually use here is PDF LaTeX. So that's already set. You don't have to bother about that. Now, in order to start a document, what is the the basic structure of how this document should look like? So it will look something like this. The first and foremost important step that you need to have is something known as a document class. Okay. So this is a form of how a command looks like. For those who are not familiar with LaTeX, those who are because I'm teaching you the basics from 101. So you can say this is how a command looks like. You can say there's a slash symbol, and you have a document class, a command known as document class like this. So, okay. Now, then after that, we write some package imports like this. and then we can have some global definitions. And this is the another major portion that is I have to mention. So the first important portion was this one. You can see document class, and the second important portion is this one. That is, this is known as an environment. So what is an environment is something that starts with the command begin and something that ends with the command end. So whenever you have a command, you can see you have a special symbol there that is known as that slash. Okay, it's a backslash. So you have a backslash like this, and then you have the command begin and then something inside brackets. Similarly, you have a backslash here and a command end, then something inside the bracket. So I'll come to the details what it is. So this is similar to if you're familiar with HTML, hypertext markup language, where you have two parts in a, when you look at the web page, you have two parts like the head and the body. So inside the body part, you have the contents that is displayed on the browser. Okay, so similarly here also, whatever content you write inside this begin document and end document is what comes as the output of your, or what to say, on your PDF file, onto your PDF file, or that is what you maybe is a seminar report. So if you want the contents of the seminar report, it has to be written inside this. Okay, so that is how it works. Now, this is what I was talking about. It begins with the backslash command. Every command that you want to write, it is mandatory that you should have to start with the backslash. And it is case sensitive. Case sensitive means what? You cannot just, as you wish, you cannot just reverse small letters and capital letters. So it usually follows, both are there, small and capital, both are there, but it will contain only of letters. The commands will not have any numbers usually. It will be usually letters or alphabets only. Now, and there is something known as parameter or argument. So, if those who are familiar with programming languages will know what are these. So like you write something and then you want to add on some extra features to it. So you can say that is maybe known as arguments or parameters. Okay, so that is one thing. Okay, now the next thing is how do you write these arguments? So either you can have a curly brace like this, or you can have a square bracket like this. So that is how it generally looks like. So when I just come back to this, you can see how many types of brackets are there. See, this is one kind, this is one kind, and this is another kind. So here also you can see when you're using some importing some packages, you have a bracket like this, you have a bracket like this. So you can see begin document. Look at that. Begin document, it contains a curly brace like this and an opening and a closing curly brace. So this is how it works. So then you have arguments also. Now, then I already told you about environments, and this is how a document looks like. So in order to give you an intro on how to work in Overleaf, this is how it looks like. So just go to overleaf.com and you can see you have to register, you have to log in and register. I have already registered, so I can show you that now. So just there'll be an icon for this button for registering and a button for logging in if you're already an existing user. Just register there with your Google ID, and you can. I'll give you a link if you want to how to see to follow up on Overleaf. So this is an example. Now, once you come into Overleaf, if I am an existing user, so I have a lot of repository that I've created so far, and this is the one I created for today. Okay. Now, all the projects that I've done so far will be there. Okay. I hope this web page is visible. Is it visible?
Yes,
The
ma'am.
web page is visible. Okay. So IEEE, this is a project that I just created now. You can just log in and register from here and then create a new project. Okay, create a new project. You want a blank project, example project, or there are many n number of templates that are available in Overleaf. Like you can see so many templates, even for creating a resume presentation, whatever document you want to create. So when I say documents, I'm imagining you all are degree students or postgraduate or graduate students. So I am just talking of seminar reports, project reports and all that. You can also create templates for presentations. The presentation that you see here, this is done in LaTeX. Okay, this is done by the tool in this document class will be Beamer, Beamer. So Beamer is the tool used for creating a presentation. So similarly, you can have conference reports, thesis report, whatever you want to create. Many kinds of documents are available in that. So we'll see this. So after you create a project, this is a project that I've created. You log into or you enter into the project, and in order to add a file, you can have a new file like this. So suppose I'm typing it, naming it as something, example.tech, and you create it. So this is a file I just created. And the first thing that you have to do here is, so because at least all the other examples I've already set it, I just have to compile and show you. But this one, because this is the first document that we're going to create, I'll just type it for you. Document class. So while you type, so how many auto types are there, you can just click on that. And what is the kind of report or what is the kind of document that you're creating has to be has to be written in the argument bracket, curly bracket. Curly bracket means it is mandatory argument. What is meant by mandatory? It's important. You have to write something there. You cannot leave it blank. Okay, so square bracket is for optional arguments. So if you have to have a square bracket, we need to know the format. So slash document class should be the first line of the LaTeX command. Okay, in order to show what kind of document you're creating. So I can write article. Article means a short document. That is one thing. And then I told you the second important statement is begin document and end document. So begin curly bracket document. If you can just click on it, the environment will automatically come. So if you're beginners, I always that you start do it by typing. Okay. So document class article, begin document, end document. Now inside this, I'm going to write whatever text I want the PDF to be displayed on. So I write hello, all programmers. First sentence that will be or they'll be writing is known as hello world. So I'll just write hello world and I'll compile it. So you can see a button over here for compiling. Like if you have guys have run like C or Java or any sort of coding languages or programming languages, if you worked with, you know what is meant by compiling. It's basically a kind of execution. You just execute it so that you get an output. I do not know why it is taking time.
Ma'am, you
Yes.
can change the compile time from normal to fast, so it may be.
No, yeah. I think something just went wrong now because till now it was working fine. I'll just see if I can compile this, but it's still working. Something, yeah, I think something has gone wrong. Anyway, maybe some net issue, I don't know, but I think I had already compiled this, but I'm not able to stop it now. I'll just exit from it. Yes, it's working fine. There's something wrong with this document. Just recompile. Yeah. So this is another example. I've just said the same thing. So the only difference here you can see is I put some optional arguments here. So I'll just delete it for the time being just to avoid the confusion. So you can see document class, article, begin document, end document. And I've written two statements here, hello world and then attending LaTeX class. So this is the output that you get. This is a PDF file. Okay, so the advantage of using overlay fields, you can in parallel, you can see the code as well as the output that you want to generate. So this is the advantage of this. Now we'll move on to the next topic. So this is a general idea of how you want to create a basic document, a very simple file for beginners. Okay. Now we'll move on to what all can be added as options. So these are some of the options. Options, I mean, I said this is a basic output that is by default a PDF file, maybe of size A4 and some font size they are put in. So if you want to change something, you can give some more options. So that is where you bring in the optional arguments. Okay. So what are the optional arguments? What is the size of the paper? Like, is it A4? And what is the preferred font size that LaTeX they suggest is either 10 point, 11 or 12, not more than that. Of course, if when you're putting the normal text should have 12 points. So if you're putting 12, that means you'll have the headings will be dependent according to what is a normal text. So maybe if the normal text like the text somewhere over here, it is 12 point. You can see the heading is maybe 16 or 18 or something like that. So they will adjust the heading size now. So this 10, 11 or 12, either one of them you can use. Then you must have seen IEEE papers, all of you, especially or any journal or transaction, or you can say any conference papers, they will have a format known as two column. So if you want two column format, you can have a two column format. If you want to change the orientation of this LaTeX thing from portrait to landscape to look at this direction, you can also have that. So these are the different options. So when I come back to this, so that is what was here. You can see how we write the options. In a square bracket, you can have A4 paper, comma, 12 pt. That means this should be in a 12-point font, and the paper size, the output when it comes for a print in the printable format, it should be of A4 size. So that is how they're going to set the PDF. You can also do one thing. If you want, you can, there's one more kind of thing that you can add. The document type is also known as report. So for seminar reports and larger documents like seminar, project, PCs, etc., you can use the document class known as report. Okay, so that is how you just have to change this. So if it is a beamer, if it's a PPT that you want to create, you write beamer here. If it is some maybe some conference proceeding, there will be some title there. So it depends. They are predefined. It's all predefined. Okay, so this is how it's going to work. Now we'll move on to the rest of the topics. So these are the different types of document class I told you. Article we have seen, report we have seen, then there is book, there is a letter format, there is a beamer format, etc. Now, in the beginning, when I showed you the document structure, there was something known as importing of the packages here. So all of you know when like in C and C++ or Java or whatever it is, you must be having some sort of methods for bringing in packages or what you say any other functions that are written already and predefined. You can bring it to your program, right? So here also, depending on your branch, maybe you're from civil or you're from mechanical or whatever it is. So there will be many options of how you can represent something. So maybe because this is an open source thing, a lot of packages have been developed or contributed by a lot of people. So you can see you can bring in that package by just using the command /use package and the options that are available for the package and the name of the package here. So this should be the name of the package. Okay. So similarly here also I am going to show that. So you can have /use package, any package name that you want. So the commonly used packages are like GraphicX because in order to insert an image or a figure inside your report or document or whatever it is, you need to have a package for inserting because the function call, you can say the function or the code that supports this is available in GraphicX. So you can write /use package and what should be the name of the package, you can just write GraphicX. Okay, so that's all. You can just write GraphicX. Now, next is another package known as AMS Math. So what is AMS math? AMS math is basically American Mathematical Society. That is a society, you can say, which actually is much into mathematical font and formattings and all. So this package will contain all the things related to, you can say, the maths related fonts and symbols, Greek symbols, or any kind of notations that you want for mathematics. And for seminar reports and all, if you want to add some headers and footers, I generally prefer this particular package, that is Fancy HPR. It's a good one. But to go into detail, we need a lot of time. So this is just an idea of how we can do it. Okay. Now, one example is another thing that I want to mention is something related to special characters that are there. So if you come and look at this particular code, you can see there are some special characters here, like backslash is a special character, bracket is a special character, curly brace is a special character. You can see two backslashes here, that is another special character. So suppose that if you want to comment something, I'm assuming all of you know what is meant by a comment. So when in programming languages, if you want to give some documentation, you want to give some extra knowledge to the user who is reading the code, you can actually use comment symbols. So the comment symbol is actually the percentage symbol in LaTeX. So if you want to comment something, the symbol that it use is percentage. So what happens when you put a percentage is this entire line, that is you can see here, this entire line becomes unexecutable. So when I just compile it, see look at the output. Actually, there was no issue. I think maybe because I'm pressing it, it's becoming slow. The thing is, the output will be I am, and the rest of the things that you see here will not be executed. Why? Because it is a comment. What is the purpose of a comment? Comment means you should not have to execute it and bring it to the output. So when I put a percentage symbol there, the rest of the line, that is still the full stop or till the end of the line, you can say it will not be executed and won't be there in the output. Okay, so it will be hello world and I am. That's all. So that is all it will be there. So what you can do is, so the thing is that I wanted to write, I actually didn't intend to comment it. So what can be done to avoid that? Say if I wanted to write, she got 85% marks in her exam. Suppose this is what I intended to write. Now, my intention was to write 85%, but what happened, LaTeX misunderstood it as a comment, and the percentage symbol onwards, it is not going to execute. Okay, so that was the issue here. So, so disappointing that I'm not able to compile it and show it to you guys. So anyway, this is what it will happen. So I'll be writing, so the output will be something like this. Hello world, I am attending LaTeX class and she got 85. And the rest of the things that you see here in the blue font will not be coming there now. Okay, so that is how it is going to work. Okay. So that is the basic idea of, we'll come back to that slide and see if it compiles by then, of special characters. Now what can be done to avoid this? So what can be done to avoid this is, you put a backslash before it like this, see? And I put an extra backslash before that, see how the font format also changed? Yeah, so you can see here, when this was the case, it's not working. You can see the output in the case where I put a backslash here. This is how we got the entire thing in the output, showing that this is a, that it actually is not treated as that. LaTeX compiler does not treat it as a comment. Instead, it tries to print it in the output. So you can see here when you put a backslash. So that sequence, that putting a backslash is known as escaping the special character. So if you want that something should not be treated by LaTeX as a special character, you have to escape it and bring it to the output. Okay. So how do you escape it? Put a backslash before it. So that is the general idea. So everywhere you have to put a backslash like that. And spacing also. You can see spacing, LaTeX actually ignores any kind of white space that we put extra. Just one empty space between, say, between and empty, if there's a single space, it will be treated as it is. That is, these are two different words, no problem is there. But if you put multiple space or multiple new lines or something, it will not be treated as multiple spaces or multiple new lines. Instead, it will be treated only as a single empty space or a single new line. So that is a general idea. Now, suppose that, so when it ignores space, what can be done for that? So that is what we are going to see. So you can see here, if I do not put up these things over here, you can see double slash two backslashes are there, right? So I just ignore that. I'm actually in the code, I'm writing it in 3 lines. Hello world, I am attending LaTeX class and she got 85% marks. Isn't it? So meanwhile, somebody can give me an idea whether you're understanding by the time it compiles. Is it okay? Did you get an idea of how to start a basic document?
Yes, ma'am.
Okay. So I can give you a link like after this class, maybe I'll just put it in chat where you can go into Overleaf and create an account. Okay, so I'll just do that. Okay. Okay, I think because I'm presenting it is very slow, I do not know why it's so. This is output of the previous one where we commented the statement, you remember? So now let us compile this one and see if it works. This is not at all usually like this. Those who have used Overleaf will know that. I think because I'm using it through the presentation, that is why it is becoming very slow. Okay. So let it come. By that time, I'll come back to the slide. So the next thing is spacing. It is what you say. It is ignored. So if spacing is ignored and you want to actually get a new line, that is, you want to move to the next lines. Okay, then what you can do? You can either use a simple two backslashes. Okay, that is one option, or you can use the command slash new line. The one advantage of LaTeX is that all the commands that you see here are the names are very user friendly. Like if you want to create a new line, usually what will be the command? It will be slash new line. Okay. If you want to write a mathematical symbol like alpha or beta, the command will look something like this. It will look something like this, alpha. Okay. So this is how it's going to look. Alpha. Okay, that is it's very simple. That is it's very user friendly. If you want to write out some command, the thing the output that you want it to appear the same command. The name must be used for the command also. Most of the cases, but sometimes there are a few changes. So that is why you cannot remember all of them. So Google will be a very great help if you are not able to remember some of the commands. So that is how it works. So this is the output I wanted to show you. That is, hello world, I am attending and she got 85% marks. All these are written in different lines. But because LaTeX ignores multiple white spaces, see how the output came. It came in a single line. So you can actually start writing and typing from anywhere and you don't have to worry about the alignment of this document. There's no need to worry because everything will come in a single line. But now suppose that you want that it should be appearing in different lines, you can put two backslashes here. Or you can do one somewhere like write new line, something like that. You can write a command new line. So if I do something like this, then you can have the sentences in different lines. So this is the basic idea. Okay. Now I'll show you how to create a basic document like with adding some title page and then coming to the sectioning part, like how to create an abstract, how to create chapter, how to create section, subsection, etc. So because these are the basic parts of your report, right? So we'll come to that by looking at directly the code. The thing is that if I'm not able to compile it, so I'll just give it for compilation by the time being. Okay, so in order to create, suppose the document class report I'm creating, I can create a title page like this. Like I can give the command like slash title. It's all predefined. Okay, I haven't created this, all available in LaTeX. You can give inside the bracket the name of the project is your wish. You can give it. Then author name, like my name and my college name or my address I've given here. Then date, there's another command like today. It's like I want today's date. So if you want, if you can see this PPT, when I started, I have the today's date. Actually, I didn't type it down. I use the command slash today and I compile this LaTeX code. So what happened is today's date was automatically picked and it was put in there. So every day I go for a presentation, I just recompile it. Okay. So similarly here also, if you want to submit a document today, you can just recompile it and today's date will be applicable. Or if not, you can just type something here. Okay, whatever date you want. If I want June 2000, you can write your own format there, whatever you want. Okay, so whatever contents you have for date, title, and order, all those things can be written over here. Okay, I hope this is okay. Now, the next thing is our begin document, and begin document should always be ended with the end document. So it's mandatory that if you have a pair of commands like this, you have to begin it also and you have to end it also. You cannot just leave it out, it will be an error. Okay, so those who know programming will know that. So, like when you write, if for a function, if you have an opening bracket, it's mandatory that you should have a closing bracket. So, similarly like that. So when these three are written, you can see it is written in the preamble. What is meant by the preamble? The portion that comes before begin document and after document class. That is, you can see that these two major statements are there, document class and begin document. And inside that, you can have some global definitions like these. So title, author, and date are some global definitions like that. And in order to bring it inside the document, there is one more command known as make title. Okay, that is the important thing. Now let us come to how to create an abstract. So I'll skip these for the time being. So how to create an abstract. So begin abstract, end abstract. That is the command. It's another environment. Got it? Is another environment. You add some content here. You can type any content, and in between, if I want to start a new line, I don't actually have to go to a new line. I can just start it from here. Just type double slash and type some content. That's all. So whatever is your wish, you can write it in some any format you want over here. It need not be aligned, need not be organized. But you can say come back and see the output very clearly there. Now, so begin abstract and end abstract gives you an abstract. Or if you know what is an abstract, like the introduction part of the document, then giving a summary of what your document contains. Now, in order to create a chapter, the command is very simple. Just use the command slash chapter. So the chapter command is only available in the report kind of document. It's not available in the article kind of document. So if you're creating an article, you should start your first section by using the command section, not chapter. Okay, so that is one thing you have to note. If you're using the document type report, then chapter is available there. So that is why I prefer that when you're creating a seminar report or a thesis or a project report or any kind of mini project, whatever it is, you should always use a report kind of document. So slash chapter, give the title of the chapter. So I gave the chapter title like this, introduction. Got it. Then my first LaTeX doc, I wrote some command, and then we've got the section command. So section means what? All of you know what is chapter, right? So you can see here, I'm not giving any chapter number or anything. All these things will be automatically done by LaTeX. The only thing I'm doing here is I'm just giving the name of the chapter. So this name has to be given, the title. That's all. Then write some content if it is there at all. Otherwise, you can start the first section. So underneath the chapter, when you start the section, this will be numbered as chapter 1. Got it? And the section that comes under immediately after the chapter will be numbered as 1.1, right? Because it is a section under a chapter. So chapter 1 in there, you can say the chapter 1's first section. So that is whatever name you want, you can give there also. Then give some content. Okay. And then the next part is subsection here. Okay, subsection and the content of the subsection and so on. So how does it come? Let us number it. So this will be numbered as 1. Sorry, 1. This will be numbered as 1.1. Got it? Subsection is under the section, right? Under the chapter also. So chapter number dot section number dot subsection numbers. So this is how it's going to be. Now what will be the number for this? This is the second section inside the first chapter. So chapter number is 1, dot section number is 2. This automatic numbering will be done by them. We don't have to bother about it. And so on. Okay, I'm going to delete this. So automatic numbering will be done. Now suppose that you want to start a new chapter. What do you have to do? After all the sections and subsections, if there are any, you do this, and the next thing is you create another chapter. So write the name of the chapter again. And this will be numbered automatically as chapter number 2. And the section under chapter number 2 will be automatically numbered as 2.1. Okay, so this way you will be able to do a number of chapters as well as sections. Now, a special case when you come to the end of the report, you have basically two things. Either you have got you'll be having a bibliography or a reference, and you'll be also having an appendix section. Now, what is the purpose of the appendix section? If you want to add something extra that is not relevant or so important to be put inside the document, you can put it towards the appendix or something extra. Say for a computer or those who are coding will be knowing that during the appendix section, what we usually do is we put in the sample code, and maybe if you're doing a project with a lot of GUIs on, you can put in the screenshots, or if you have some graphs, you can put it there. You have some tables or log tables or something like that, some readings that you collected. All those things can be put in the appendix section. So appendix also contains chapters, sections, subsections, etc. All these things are there also. Now, how do you identify or differentiate between this is that you have to start a command. So look at this line number 28. You need to start a command known as appendix in the beginning. So put a command like /appendix. Okay, it's appendix. And you write the command and then start the chapter. So automatically, you can imagine the chapter numbering will be different. Either it will be some alphabets like A, B, C, D, etc. Okay, so this will be named as chapter A. Got it? Chapter A. Now, if you had a section below this, say if I'm writing a section, okay, if I'm writing it as a section like this, I write the something like, so this will be numbered as A.1. So either it can be alphabets, capital alphabets, or it can be Roman numerals like 1, 2, 3, etc. Whatever. So it depends on the default format that LaTeX follows. Okay. So A.1, then this will be numbered as chapter B. The section under this will be numbered as B.1. Subsection will be B.1.1, etc. etc. Thank you. So I'm really disappointed I could not show you the output. Or I had it all compiled, but because now I had to recompile it again. Yeah. I tried sharing only the window, but everything I'll have to switch. That is a problem here. So this is how it looks like. See, title, author, and date. I asked you to put a make title over here inside the begin document. Look at that. Inside the begin document, I want the title, author, and date to come, right? Not outside. So this is where your begin document comes in. That is the report that the PDF that you're seeing here is where your document starts from. So if I put make title here, these three entries over here will come over here. So this is how it looks like. Title, the name of the author, and the uh, date, today's date or whatever it is. Okay. I compiled it way before writing June 2000, right? So that is why today's date is there, March 31st, 2020. Okay. Then I had three commands like table of contents, list of figures, and list of tables. So look at these. So these are just a single line, a single word you can say that is just merged together like this table of contents. What does it do? What does it do? It took all the chapters, all the sections, all the subsections, and all the appendices that were there, all of them were taken, the numbers were taken, the titles were taken, and the page numbers were taken, and they automatically aligned it for you. So you see how beautiful this is. Look at that. Okay, so that is how contents was created. And similarly, you can have a figure number, the title or the description of the figure, caption, you can say, the caption of the figure and the page number. Similarly, list of tables, etc., etc. But you know that in this document, I haven't added any figure or table. That is why it is not there, it's blank. So that is one thing. Then my abstract, so you can see the abstract that I added here, this one. Okay, that's some abstract here will be there. Then the chapter starts. It's so easy it is to create. You just have to write chapter, the name of the chapter, and paste your content. So chapter, this is how it looks like. The automatic numbering is given, chapter 1. And look at that, the first subsection of it, line number 15. That is the section 1, right? So it will be 1.1. Look at the font size, how it changes. This is by default, I haven't given anything, right? So it is by default 10 point. If you want to make it 12 point, you can put a square bracket here and write 12 pt. Okay, and automatically this font that you see here, this will become 12. Okay, now currently it is 10. So based on whether this is 10, this will be maybe some 14, this will be 18 or something like that. They will arrange it automatically. Okay, the compiler will do it for you. And then subsection you have 1.1.1, the second section 1.2 and so on. This is how it looks like. See, it's the second chapter. Appendix A, the name of the chapter, etc. Second appendix, name of the chapter, etc. And look at all the page numbers, everything comes in. Okay. See, that was the issue. I shared my entire screen, so maybe that is why it was not compiling. Now see so quick. So this is how it looks like. So I've created a very good with content, a document for you to see how it looks like. See how an abstract looks like. This is how it looks like. Then the chapter, how the section and the paragraphs look like. See how the page numbers are aligned automatically. You can see all of them are justified. You don't have to justify it. So whenever I want to start a new paragraph, either I can write, I can leave an empty space like this to start a new paragraph. Wherever I've left an empty space, a new paragraph starts. Or you can have options for commands are there for adding paragraphs like slash paragraph. Or you can have a new line here. You can write new line also here. Either way. If you want to leave a new line, you can write this simply new line and so on. So subsection, etc., etc., etc. You can see. I'm just scrolling through. Second chapter, sample code. Look at the sample code. So this is an example of how a code can be added. This is some random text I've taken from Ipsum. Okay, so this is how it looks like. So if I want to add, that is, it should not exist. You can see some special characters are there, like bracket, multiplication symbol, all these special characters are there. I do not want that LaTeX should execute these special characters. So you can enclose it in something known as verbatim. Verbatim is an environment which starts with begin and ends with end verbatim. What is the purpose of verbatim? It should be exactly copied to the output. That is the meaning of it. Okay, so that is how I do these commands. You can see. Yeah. So this is how I do the commands in the PPT. I have shown many commands, right? So the LaTeX should not execute those commands. All of them should come directly to the output. So this is how you can. So this is an example of a Python code and see how the exact format is replicated here because I wrote it in verbatim. Okay. And some screenshots I've added in the no images there. I just put some content here. You can add images also. So this is how it looks like. Okay. So we move on to the next one, that is adding figures. So how do you insert a figure? The first thing that you have to do is you have to use the package, use package graphic X. Okay, I told you because figures cannot be directly added. You have to, add an extra package for doing that. If you're using your offline tool, actually it will be there by default. Okay, my image has not been loaded because I think I'm on a new machine. I was working on my laptop before, so maybe that is why this happened. So anyway, okay, look at that. So use package graphic X. This is the image that I want to add an image. So the first thing you have to do is add this package, and where do you add it? Between these two statements, document class and begin document. Okay, then I simply started a chapter and a section and I added some command and all those things. Now, in order to add a figure, it's there in the PPT, but because I have to switch between this and that, so I'm just explaining it from here itself. You can see the command used is begin figure and end figure. This is actually the environment that supports the figure. Why I need an environment is because you can look at the output. Suppose the figure was here, and you can see there is a caption. So you look at that figure 1.1 ABC logo. There's a caption there, right? So if in order to add a caption, then in order to refer to the figure, like adding a label, you can refer to, you must have seen in the textbooks, there'll be a statement like whenever there is a figure or whenever there is a table, some description will be written about it. Like in table 1.1, so and so is described, or in figure 2.2, so and so is described. So everywhere, wherever you want the figure number to be automatically referred to. So you can see this line. I'll just zoom it for you. See, look at that. The figure 1.1 shows the logo of this college. So I've written that there. So you can say, the statement is over here. See, I've used this command here. Like the label I've written over here, this is the label, and I've given a name for this figure, like fig1. Okay. And the same name, I've referred it inside the text. So this is the text here. The text here, I have written ref of fig1. That means whatever the LaTeX compiler gives this figure a number, right? It is 1.1. I do not have to bother about what is the number. So even if I change this figure from this location to some other chapter, if I'm referring it from here, suppose the chapter changes and the figure number now becomes 2.1, automatically this here also it will be updated as 2.1 because I'm referring to the alias name of the figure. Whatever be the actual description of the figure, I prefer to remember it using the name fig1. So I just write /ref of fig1. Okay, so begin figure, end figure, and inside that, the main command is this. This is the main command that actually adds the figure into your document. What is the name of the command? /include graphics. Now, why did we add this package here, this graphic X? We added it here so that we can use this particular function or command. Okay, what is the purpose of this is, if you are ignoring all these, let me ignore all this, this is the basic purpose. Like /include graphics, bracket, inside bracket you write the name of the figure. So actually the figure is uploaded over here, but I think I copied it. So maybe that is why when I change the reference has changed. It's actually here. This is the figure. Okay. I'll come back to this. Let me decompile and see if it's working. Okay. So come back to the figure and see whether it's working now. Okay, I think the reference has changed. So leave it. So the figure will be there. So you can see this is the figure that I've imported. So when you add include graphics like this, automatically the reference will be there. I'm actually logged in on my laptop also, and I just changed to an entirely new system for this particular purpose. Okay, so this is how it looks like. Okay, now you can have many options, but because we are short of time, I won't go into that. And this is how you generally add a figure. Okay, and we'll look at the next one, that is tables. So I'll just compile this. Creating table is actually not so easy when you compare it with Word usually, because this is the output, how it looks like. You can see creating a table actually requires two commands. So you need to have two environments actually. The first one is, you can see here, begin table. So look at that, begin table and its corresponding pair, that is end table. Now, why do we need this table environment? Is similarly like before, for adding a caption and for adding a label. So all these, both figures and tables, are actually known as floats because they tend to move around on their own in the document. Okay, we cannot actually control them and keep it there, and it is not usually preferred by the LaTeX creators and all. So wherever there is space, they try to go and adjust themselves. So if suppose that a lot of this table is not being able to adjust in this area, what they will do is the content that comes below this table will be automatically filled here so that it does not look awkward, and the table will go to the next page. Okay, so if you have enough content, this area where there is the table cannot be fitted, automatically they will align the content and the table. So the two environments are begin table and end table. You can see that, right? So, and inside that, for actually creating the table, you need another environment known as tableau. So this is not so easy. So that is why there's another method where you can have this coding, like you can have uh, a page like tablegenerator.com like this. So automatically, I think you can, like you do in Word, you can select what set up the new table. Okay, you can set up the new table like this. Like you can select how many columns or rows you want like this, and you can type the content here if you want, or you can copy paste the content, whatever it is. So when you do this and you click on generate, you can see automatically the content will be there. See this. Now, what is the specialty of what you see here is, I'll come back to the table code. This begin tabular is what actually creates the table I told you, right? Now you can see inside this curly bracket, there are some things written. Okay, so everything has to be defined if you want to create a table. Like you can see this in this, the vertical bar that is there and the horizontal lines that are there. The vertical line that goes down and the horizontal lines. All this has to be defined. Okay, even that. So even if I skip one of them, say suppose I'm skipping the outermost bar symbols here and I recompile this, it will look like this. Because the pipe symbol that I used here, you can see the pipe symbol that I used here was actually meant for the boundary, the leftmost boundary. And the pipe symbol that I'm using after each letter C, you can see it is basically the rightmost boundary. So this is how it looks like. Okay, when I compile this again, you can see the boundaries will come back. Okay, so CCC. Now, what is CCC defines is the number of columns basically and the alignment of the column. So, if I put only two pipe symbols, that means there is only one column. So now you can see there is a column here. This is the first column. This is the second column. This is the third column. And C refers to the alignment. So I can actually put L, and C also. Means left alignment, center alignment. That is the basic idea. So if I try to recompile it, you can see date, yesterday, today, price 160 and 264, 234 are all left aligned. Whereas the last column that you see here are center aligned. So I can also use the right alignment here. So different kinds of alignments are there, left, right, center. So see, these are the different kinds of alignments. Now, the next thing that you have to notice, the separation between the rows and the columns. So the columns are defined by these three things. As many pipe symbol you do, that many number of columns will be created and the boundaries also will be created. Now, how do you separate the value inside the column? Using the ampersand command. Okay, using the ampersand command, you can separate the values inside each column, each cell. So date and price and item. What is the meaning of that? Put it in three different cells. and you want to move to the new row, right? So we have already learned how to move to a new line. That is nothing but the new line symbol. What is the new line symbol? Double backslash. Either like this or slash new line. You can write both. But here we usually use double backslash. So double backslash indicates moving to the next row. Now, suppose that you want that, suppose I omit this particular H line. What is meant by H line is horizontal line. So look at that. Horizontal line means cover this particular cell with the horizontal ruler or a horizontal scale or something like that. So if I put a H line symbol here, then automatically you can see it will come back. Got that? So this is how you create a table in general. Now, mathematical equations or references, I think we do not have time for that, but without showing, because the reason why LaTeX was created was basically for creating mathematical equations. And it sets out very beautiful mathematical equations. So at least I can show that now. So I told it's not a 1 hour session. This has to be a workshop actually in order to understand it much more better. But still, there are a lot of online resources available. You can learn, like topics are there, like learn LaTeX in 30 minutes, 1 hour, LaTeX for dummies. So many things are there. So you can just take on those PDFs and you can start working on that. So we'll see this some mathematical equations. Like if you want to create a equation that comes along with the sentence, that is known as an inline equation. Okay, we call it as an inline equation. Mathematical equations are basically created with, basically you can say the most important common syntax that is used is a dollar sign, because this is actually currently compiling, it will show the errors. Okay, don't just ignore that. You put a dollar sign in the beginning, you put a dollar sign at the end, and in between you can write this command a plus b is equal to c. Suppose this is the equation, and if I compile it, it will look like this. See this, but because I put it in the same line, it came in the same line, put a new line symbol here and compile it again. See this, a plus b is equal to c. Look at the font of how beautiful it is, isn't it? It's not like you write a normal text. And if you want, you can compare it with any other text that you normally, because it will be emphasized. If I simply write a plus b is equal to c, it does not look as good as when you write it inside the math mode. So you look at that. This is the second statement that I wrote, and this is the actual equation that I wrote. Okay, so you can compare these. So what you have to do is put a simple basic dollar sign to start something known as a math mode. Okay, so this is how you write E is equal to MC square. So MC square, you can say, because it is a superscript and a subscript. So superscript is denoted by the symbol, cap symbol like this, or a hat symbol. So M into C raised to 2. So that automatically it comes here raised to 2. So if you have a lot of equations in your report, always LaTeX is the most preferable. Okay, that is one way of doing it. Another way of doing it is, many other options are there, like you can have a backslash and a round bracket to end it by a backslash and a closing round bracket. Or you can have a command known as begin math and end math. All these are different forms of inline equations. What is meant by inline? It goes along with the text. Now look at this thing. See here, the text is here. This is an example for displayed math, but the equation stands alone. Look at that. The equation is not numbered. It stands alone on a separate line. That is known as displayed math. Got it? So for displayed math, you have to use $2 symbols. Look at that, $2 symbols like this. So that is how we go forward with that. Now the most common one is the environment known as begin equation and end equation. Got it? Begin equation and end equation. So we look at that, how it is numbered also. See the equation numbering coming. So begin equation, end equation is basically a displayed math. Displayed math means what? It stands out separately. It has an environment along itself. It does not come along with the text. So it's like a standing out equation. Okay. And it will be numbered also. That is the advantage. So many options are there, like how to create fractions, how to add matrices, how to align equations. So look at the outputs. You can look at the outputs and see how beautiful it is. See this one. And look at how summations, integrals, infinity, all this. So you can see all the commands. Infinity is written by the command like this. Summation is written by the command /sum. If you want the limits for the summation, like k is equal to 1 and raised to m, so you can just put the subscript and superscript symbols over here, just like that. Okay, so this is the general idea of doing it. And just one more thing I wanted to show you is how to, if you want to create a IEEE paper or something like a computer society, that is our society that is hosting this, they themselves have their, what do you say, um, conferences. So you can see these templates are already available. You just have to go and search in LaTeX or the template in Overleaf. Sorry, in Overleaf, what is the template for an IEEE journal, IEEE transaction, or whatever you want. So the type you can see this the basic class, the document type here is something known as it's a document class. That's why it's written as CLS. Like we wrote report, article, etc., right? So let us come to the code for this. These are all commands for your help. See how they're written. The document class starts here, and it is a conference for computer society. These are the optional arguments they have already predefined. And this is a document class that is IEEE tran. IEEE tran automatically, it will come in this format. And you can see the next thing is all these are citations. Comments, not citation, comments. You can skip all this and you can start your coding. Or if you want to start doing a paper, you just have to come to this basic thing. All these are your help files, so just delete it if it is not needed. If you want to add something extra, this is how you do it. Okay. Now this is where you start over here. See, if you want to put your title, say bare demo of IEEE Translate. So just the title command is already here. So whatever is your seminar or project report, just put your title over here. The template is readily available. If you want to put the author names, you have to put it in author inside the author command, inside IEEE author block. N means name, and you can put the name here and the address of the author here. It will come like this. See, look at this author. It will come like this. So if you want 3 different authors, you just have to put an and symbol in between, A and B. Second author, and third author, etc., etc. And then comes the remaining portion, that is the content. And you have to put the main title like before so that it actually comes in the document. Begin abstract, end abstract, that we already learned. Then we have got a section, because this is an article kind of document, does not have chapters. You start with a section, introduction. See, this is the introduction section. Then you have, different subsections, sections, acknowledgement, references, etc., etc. Okay. So I know I was a little fast, but was it at least understandable for those who are there? Is it okay?
Yes, ma'am.
Okay. Okay, so this is the basic idea of how you can start with a document. So my first this thing is that you go to Overleaf. I put it in the chat box, or you can just Google it overleaf.com and create an account. And there are so many readily available templates, especially for your graduates and all. You're going for a job interview. There are many good templates for resumes also. So I suggest that you please go through it. And if you have any doubts, you can contact me at my email ID. It is like, I'll just type it here. And if you want any such future workshops, we are ready, eager to come over here at Amalajyoti, and we'll be conducting one workshop for you for sure. So thank you so much, Akash, for inviting me. And thank you all participants for your patient listening. Thank you so much.
Thank you, ma'am. Hi, guys. So I hope you have learned something from the session, and yes, it was informative. Uh, from scratch, I think the session was really explanatory, self-explanatory. So yeah. Also, I have posted a feedback form in the chat. Please go through it. Mark your name and email for availing certificates, and the record sessions. As you know, LaTeX is actually something we need in future also, right? So it will be uploaded in our YouTube video, YouTube channel. Yeah, that's all from today's session. Thank you, ma'am, for accepting the invitation.
Okay, thank you everyone. Have a good night. Thank you.